18 plus 1 by iota to the power 25 whole to the power 3. Right. So we have already done that iota square is equal to -1. However, 1 by iota can be written iota divided by iota square on multiplying and dividing by iota. It becomes iota divided by -1, which is equal to minus iota. So in this question, iota to the power 18 means iota square to the power 9 plus, similarly 1 by iota means minus iota to the power 25, now whole to the power 3. But iota square is -1, that gives you -1 to the power 9. Again, minus to the power 25 will be negative only. That gives you iota to the power 25, which can be written iota square to the power 12 into iota whole to the power 3. Again, -1 to the odd power -1. This minus as it is. Iota square is again -1 to the power even, that is plus into iota whole to the power 3. Let's see it again. Iota to the power 18 means iota square to the power 9 plus as it is. We have already proved that 1 by iota is equal to minus iota. So it can be written minus iota to the power 25. That gives you -1 to the power 25, which is negative there. Iota to the power 25 means iota square to the power 12. That makes it 24 into iota 25. Right. Now we can open it. Applying a plus b whole cube. This is a cube plus b cube plus 3a square b plus 3b square into a. That gives -1. Again we have proved that iota cube is equal to iota square into iota, which is equal to minus iota. Write it minus iota. -1 square again plus, this is 3 iota only. Iota square is again -1, -1 -1, again it is plus 3. So complete answer is 3 minus 1, 2 plus 2 iota. Right. Similarly, for second question here, we have to prove that Z1 and Z2 are two complex numbers. So let's assume that Z1 is x1 plus iota y1, Z2 is x2 plus iota y2, where this x1, x2, y1, y2, all these belongs to set of real numbers. We have to prove that real part of Z1 into Z1, 2 sorry, we need to prove that real part of Z1 into Z2 is equal to real part of Z1 into real part of Z2 minus imaginary part of Z1 into imaginary part of Z2. First of all, let me tell you what is x1 here. X1 is the real part of Z1 and x2 is the real part of Z2. Similarly, y1, y2 are correspondingly imaginary part of Z1 and Z2. So let's write it here. Real part of Z1 is equal to x1. Real part of Z2 is equal to x2. Imaginary part of Z1 is equal to y1. Imaginary part of Z2 is equal, listen, y2. Similarly, we can take this right hand side. Let us find out Z1 into Z2. Z1 into Z2 is equal to x1 plus iota y1 into x2 plus iota y2. We will multiply this and we will reduce this into standard form. That gives me x1 x2 plus iota y1 x2 plus iota square y1 y2 plus iota, this is x1 y2. Again using this iota square equal to minus 1 and combining real and imaginary part. See, this is minus 1. This can be combined with this one. This is imaginary part. So that gives me x1 x2 minus y1 y2 plus iota into, this is x1 y2 plus y1 x2. Right. Now if you see this z1 z2 product, again I am writing it here. So we have proved this z1 z2 is equal to x1 x2 minus y1 y2 plus iota, this is x1 y2 plus y1 x2. Again it is of the form of a plus iota b. Again it is the standard form. Therefore if you find out the real part of z1 and z2, which is the left hand side of our answer, real part of z1 z2 is equal to what? This is the real part. What is this? x1 x2 minus y1 y2. But what is x1? Real part of z. That comes out real part of z1. What is x2? Real part of z2 minus what is y1? That gives me imaginary part of z1. What is y2? That gives me imaginary part of z2, which is equal to right hand side, hence proved. Then comes third question. In third question we have to show that, in third question again we have to reduce into standard form. Let me write it here. Reduce the complex number 1 divided by 1 minus 4 iota minus 2 divided by 1 plus iota into 3 minus 4 iota divided by 5 plus iota. Reduce this complex number into standard form. You have been already told that standard form means whenever a complex number is in the form of a plus iota b. Now we will simplify this. Let's take LCM. That gives me 1 plus iota into 1 minus 4 iota, which is equal to 1 plus iota minus 2 into 1 minus 4 iota into, again this is 3 minus 4 iota divided by 5 plus iota, which is equal to, again multiplying in the denominator, that gives me 1 minus 4 iota, this is plus iota, this is minus 4 iota square. It is 1 plus iota minus 2 minus minus plus 2 4 is 8, this is iota, into, again it is 3 minus 4 iota divided by 5 plus iota. Using iota square is equal to minus 1, it becomes plus 4. Putting the value of this iota square is equal to minus 1. It becomes 4, 4 plus 1, 5, minus 3 iota. Similarly, this is minus 1 plus 9 iota, like this. And the other term, which is equal to 3 minus 4 iota divided by 5 plus iota. Again, simplify this. That gives me 25 plus 5 iota minus 15 iota minus 3 iota square. Again this is minus 3 minus minus plus 4 iota plus 27 iota minus 36 into iota square. Again using this iota square both in the numerator as well as in the denominator, putting these equal to minus 1, it becomes plus 36 minus 3, 33 plus this is 31 iota. Similarly it is minus 1, that makes it 3, 3 plus 25, that makes it 28 minus 10 iota. This is the value of the given complex number which we are given in the beginning only. Now we will reduce in standard form. In order to reduce into standard form, we will multiply and divide by conjugate of the denominator, that is 28 plus 10 iota divided by 28 plus 10 iota, right? So this implies this complex number equal to what? Applying a minus b and a plus b in the denominator, that gives me a square minus b square. That gives me 28 square minus 10 iota square. Again multiplying in the numerator, that gives me 33 into 28. Again that gives me 310 iota square. Iota square is minus 1. Plus taking this iota common, that gives me 31 into 28 iota. This is 31 into 28 plus 330, again plus 330 only. So simplifying, we can express this again in the form of a plus iota b, where the values of a and b can be obtained by multiplying and subtracting the same, doing this one. So we have done this.